welcome back. Today we are going to be talking about structure of an atom. So we're going to go to the early ideas of how it was all discovered. Democritus, who was also Greek, developed a new theory of matter that attempted to overcome the problems of his predecessor. Democritus' ideas were based on reasoning rather than science, and he drew on teachings of two Greek philosophers who came before him, which are Leucippus and Anaxagoras. And Democritus continued to cut the stone into smaller and smaller pieces and reach a point so tiny that it could no longer be divided. And he called these small pieces of matter atoms. And he suggested that atoms were eternal and could never be destroyed. Later on, Aristotle and Plato, the two best-known philosophers of ancient Greece, as you probably know, rejected the theories of Democritus. So Aristotle accepted the theory of Empedocles, adding his own incorrect idea that the four core elements could be transformed into one another. So Democritus' theory would have to wait almost 2,000 years before being rediscovered. Alright, so now we know that Democritus was the first person to propose the existence of atoms, and according to Democritus, atoms are solid, homogeneous, and invisible. Alright, skip to a little bit later, we have John Dalton, which he was an English chemist, physicist, meteorologist, and he actually introduced the atomic theory into chemistry. And for his research into color blindness, sometimes referred as Daltonism in his honor. That's a fun fact about him. He proposed that all matter was composed of atoms, indivisible and indestructible building blocks. While all atoms of an element were identical, different elements had atoms of differing size and mass. Alright, onto his hypothesis and experiment. He hypothesized that the law of conservation of mass and the law of definite proportions could be explained using the idea of atoms. So he proposed that all matter is made of tiny invisible particles called atoms, which he imagined as solid, massy, hard particles. So he did some gas experiments, which first became possible in the 19th century. And he discovered that oxygen combined with either one or two volumes of nitric oxide in closed vessels over water provided important experimental evidence for his atomic ideas. So then these atoms of different masses were then called isotopes. Alright, so now we're going to go into defining an atom. An atom is the smallest particle of an element that maintains the properties of that element. With that, we have electrons, protons, and neutrons. So the electrons have a 1 negative charge, protons have a 1 plus charge, and neutrons have no charge at all. And an atom consists mostly of empty space around the nucleus, as you can see here in the diagram. So with that, we have the atomic numbers, which an atomic number of an atom is given by its number of protons. So the mass number of an atom is the sum of its neutrons and protons. Atoms of the same element with different numbers of neutrons are called isotopes, as we talked about before. And the atomic mass of an element is a weighted average of the masses of all of its naturally occurring isotopes. Then we have our nuclei. So that's an unstable nucleus, which tries to achieve a balanced state by giving off a neutron or a proton, and this is done through radioactive decay, which we will talk about right now. All right, so radioactive decay. So chemical reactions involve changes in the electrons surrounding an atom. And there are 3 types of radiation. We have the alpha, which is a charge of 2 plus, beta, which is a charge of 1 minus, and gamma, which has no charge. And the neutron to proton ratio of an atom's nucleus determines its stability. Also, nuclear reactions involve changes in the nucleus of an atom. Alright, before we go today, since I'm running out of time, we're going to talk about these. So we have, how we figured out is atomic number equals number of protons equals number of electrons. So mass number equals atomic number plus number of electrons.